Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. Cosmic destiny. The ultimate fate of the universe. The universe, in all its grandeur and mystery, has been a subject of fascination and inquiry for as long as humans have been capable of pondering its existence. From the twinkling stars that dot the night sky to the incomprehensible vastness that lies beyond our reach, the cosmos presents an endless tapestry of questions and mysteries. Among these, one of the most profound is the question of the universe's ultimate fate. Will it end in a slow, cold decline known as the Big Freeze, be torn apart by the relentless expansion in the Big Rip, or collapse back into a singular point in the Big Crunch? The story of the universe begins with the Big Bang, an event that occurred approximately 13.8 billion years ago. This cataclysmic explosion from a singularity marked the beginning of time and space as we understand it, setting the cosmos into a rapid expansion. Over eons, this expansion has shaped the universe, giving rise to galaxies, stars, planets, and all the myriad structures we observe today. But just as the universe had a beginning, it also suggests an inevitable end. Scientists have proposed several scenarios for how this might unfold, each as fascinating as it is daunting. One possible fate of the universe is the Big Freeze, also known as the heat death. In this scenario, the expansion of the universe continues indefinitely. As galaxies drift further apart, the formation of new stars slows and eventually ceases. The existing stars burn out, leaving behind cold remnants such as white dwarfs, neutron stars, and black holes. Over an incredibly long timescale, these black holes would eventually evaporate due to Hawking radiation, a process predicted by physicist Stephen Hawking. The universe would gradually cool down as it expands, approaching a state of maximum entropy. In the Big Freeze scenario, the universe's temperature asymptotically approaches absolute zero. Matter would be so diffuse that interactions between particles become exceedingly rare. The once vibrant and dynamic cosmos would transform into a cold, dark, and lifeless expanse. Galaxies, stars, and even atomic structures would decay into basic particles, spread thin across an incomprehensibly vast void. In this cold, dark end, time itself loses meaning, as the universe reaches a state of thermodynamic equilibrium where no further work can be performed. Another potential fate is the Big Rip, a more dramatic and violent end to the universe. This hypothesis stems from observations that the universe's expansion is accelerating, driven by a mysterious force known as dark energy. If the influence of dark energy continues to grow, it could eventually overcome all the forces holding the universe together. In this scenario, galaxies, stars, planets, and even atomic matter would be progressively torn apart. The Big Rip proposes a timeline where the accelerating expansion becomes so powerful that it first shatters galaxy clusters, then galaxies themselves. Following this, Individual stars and planets would be ripped from their orbits, and ultimately, the very fabric of matter would be torn apart. Molecules, atoms, and subatomic particles would be pulled asunder as the expansion rate accelerates towards infinity. This catastrophic end would occur over a finite period, culminating in a final, explosive disintegration of the universe. The Big Rip is a stark contrast to the slow decline of the Big Freeze. Instead of gradually fading into obscurity, the universe meets a violent and chaotic demise. The precise timing of this event depends on the nature and behavior of dark energy, which remains one of the most significant mysteries in cosmology. If dark energy behaves in a certain way, known as phantom energy, it could lead to this ultimate disintegration of the cosmos. In contrast to these scenarios of continuous expansion, the Big Crunch presents an entirely different vision for the universe's end. This hypothesis suggests that the expansion of the universe could one day halt and reverse. If the density of matter in the universe is high enough, gravitational forces could overcome the expansion, causing the universe to contract. This contraction would eventually lead to all matter collapsing back into a singularity, effectively reversing the Big Bang. The Big Crunch envisions a universe that goes through a cycle of birth, expansion, contraction, and rebirth. As the universe contracts, galaxies would draw closer together, eventually merging and heating up. Stars would collide and burn out in spectacular supernovae, and black holes would merge into even larger entities. The temperature and density of the universe would increase dramatically, culminating in a final, fiery collapse into a singularity. This cyclic model of the universe has a certain appeal, suggesting that the end of one universe might give rise to the birth of another. It raises the possibility of an eternal series of universes, each born from the ashes of its predecessor. However, current observations suggest that the density of the universe is not sufficient to trigger a Big Crunch, making this scenario less likely given our current understanding. Each of these potential endings, the Big Freeze, the Big Rip, and the Big Crunch, offers a unique perspective on the future of the cosmos. They also highlight the profound uncertainties and mysteries that still surround our understanding of the universe. The nature of dark energy, the ultimate fate of matter, and the behavior of the cosmos on the largest scales remain open questions, driving ongoing research and exploration. The Big Freeze represents a universe that fades into obscurity, where all structures and forms of energy are dissipated over an incomprehensible timescale. It's a vision of a cosmos that becomes increasingly diffuse, cold, and dark, a quiet and inevitable decline into nothingness. The concept of heat death aligns with the second law of thermodynamics, which states that entropy, or disorder, tends to increase over time in a closed system. In this view, the universe slowly reaches a state of maximum entropy, where no further useful energy transformations can occur. The Big Rip, on the other hand, is a more immediate and cataclysmic end. It suggests a universe where the mysterious force of dark energy grows stronger over time, tearing apart the very fabric of the cosmos. This scenario raises profound questions about the nature of dark energy and its ultimate influence on the universe. It's a dramatic vision of a universe that is not just expanding but accelerating towards a final, destructive conclusion. The Big Crunch offers a cyclical view of the cosmos, where the universe collapses back into a singularity, potentially giving rise to a new Big Bang. This scenario suggests a universe that is not static but dynamic, with cycles of creation and destruction. It's a concept that resonates with certain philosophical and religious ideas about the eternal nature of the cosmos, though current evidence makes this less likely. In contemplating these scenarios, we are reminded of the limits of our knowledge and the vastness of the unknown. The universe, in its immense scale and complexity, continues to challenge our understanding and inspire our curiosity. Each of these potential endings, whether a slow freeze, a violent rip, or a fiery crunch, offers a unique lens through which to view the cosmos and our place within it. These hypotheses also underscore the importance of ongoing scientific inquiry. As our observations and theories evolve, so too will our understanding of the universe's fate. Advances in technology, such as more powerful telescopes and particle accelerators, will provide new insights into the nature of dark energy, the behavior of matter under extreme conditions, and the fundamental laws that govern the cosmos. Each discovery brings us closer to unraveling the mysteries of the universe and its ultimate destiny. Yet, even as we seek to understand the end of the universe, we are reminded of its beginning and the profound journey that has led to our existence. From the initial singularity of the Big Bang to the formation of stars and galaxies, the emergence of life, and the development of consciousness, the story of the universe is one of remarkable complexity and wonder. It's a story that continues to unfold, shaped by the forces and phenomena that govern the cosmos. In contemplating the end of the universe, we also reflect on our own place in this grand narrative. We are a part of the cosmos, composed of the same fundamental particles and forces that shape the stars and galaxies. Our existence is intertwined with the universe's history, a brief moment in the vast expanse of cosmic time. This perspective invites us to appreciate the beauty and fragility of our world and the importance of our quest for knowledge. As we look to the future, the question of the universe's ultimate fate remains one of the most profound and intriguing mysteries. Whether it ends in a big freeze, a big rip, or a big crunch, the story of the cosmos is one of endless fascination and discovery. It's a story that continues to inspire our curiosity and drive our exploration, reminding us of the vast and mysterious universe that lies beyond our reach. In this quest for understanding, we are guided by the light of science and the power of human imagination. Each theory, observation, and experiment brings us closer to grasping the nature of the universe and its destiny. It's a journey that requires not just knowledge but also creativity, as we seek to envision the cosmos in all its complexity and wonder. Ultimately, the end of the universe is a concept that transcends the boundaries of science and enters the realm of philosophy and existential reflection. It challenges us to consider the nature of existence, the meaning of life, and the destiny of all things. In this contemplation, we find both humility and inspiration, a reminder of our small yet significant place in the grand tapestry of the cosmos. As we ponder the fate of the universe, we are also reminded of the importance of our own actions and choices. While we may not be able to influence the ultimate destiny of the cosmos, we can shape the future of our world and the legacy we leave behind. In the face of the vast and unknown, we are called to embrace our role as stewards of knowledge, seekers of truth, and guardians of the fragile and beautiful planet we call home. In the end, the question of the universe's fate is not just a scientific inquiry but a profound reflection on our existence and our place in the cosmos. It's a question that invites us to